Okay, good afternoon, everyone. My name is András Vékony. I'm Senior Associate at REC, and I will be your host and moderator for today's session. Very warm welcome to this new edition of the REC Energy Future Seminar Series. The goal of this seminar is to explore the various pathways in energy transition, including those that are still evolving or that are less prominent to the current public discourse. Today, we will focus on decarbonization of heavy-duty transport, where much of the conversation centers on electrification with the stationary charging and also on hydrogen. But we want to take a closer look at the potential of dynamic on the move charging electric road system. It is a field with significant possibilities, but also ongoing pilot project we have, yet raises many questions regarding infrastructure, the scale, integration, what we need to address. So to explore these challenges, we have brought together a group of experts and panelists from across the industry to guide us through this perspective today. Before we start, a quick housekeeping note: please keep your microphones muted and your cameras switch off. At least for now, we invite you to stay active in the discussion by posting your questions in the chat at any time, and in the Q&A session, we will choose from these questions and we will read these up. So to officially open the workshop, let me hand over the floor to the director of REC, László Szabó. László, the floor is yours.
Thanks a lot, András, and thanks a lot for all who came to this workshop of REC. And actually what I would like to do is that to make a very brief introduction of REC, one slide and maybe two slides about how an energy economist who is looking a bit from the distance these issues which we will talk about, how do we see this actually. So about REC, we are a small research institute based at the Corvinus University. We are some 20 economists, so we are mainly dealing with economic issues related to the energy sectors, with a focus on the power sector and on the natural gas sectors. But actually, as you are dealing with these sectors, it's very natural as well to come across with issues with transport sector, because this is a sector with high energy consumption, with high impact on the other energy sectors as well. Actually, what we do at REC, we mainly do quantitative research, so we have nice energy models around, quite many of them. One of these models is the Hungarian times model, which is actually going a bit further than a power sector or natural gas model, because it covers the whole Hungarian economy, including households and including transport sector as well. And with this model, we have started working quite intensively with the transport sector since 4 years. And since then, we built up additional models like an electric vehicle flexibility model, and we were dealing additional side issues like the ETS2 reforms and the transport poverty as well. So in the last 2 or 3 years, we worked quite intensively in the transport sector with the leadership of András, who was talking before. And let me just tell you maybe 2 slides about who do we see as energy economists, the transport sector, because from a very high perspective, what you see from the sector actually is that this is the sector where we have an issue. So, and the issue is that we see very intensive greenhouse gas emission increase. So compared to the other sector where we managed to put a limit on the emissions and even decrease them significantly, in the transport sector, what we see is an increasing trend in the last, let's say, even 20 years as well. And if we have a look at our region, or especially in Hungary, we see a very steep increasing trend in emissions in the last, let's say, 10 years as well, which results in that fact that we did not manage to reduce the transport emission. And if we focus on the heavy-duty vehicles, then the picture is even probably very similar. So we see very strong impact in these emissions. And what we also see here, again, the region and Hungary as well show even stronger emission in greenhouse gas emissions here. What is interesting to see here is that it's not only the emissions as well, but the whole, let's say, the activity of the sector is increasing. So if we move to the next slide, the big question for us, for energy economists, is whether this decoupling from the GDP growth, the decoupling of, on one hand, the transport activities, on the other hand, energy use, on the third hand, what is the greenhouse gas impact here? We didn't manage to have a really big success story here in the European Union, and neither in Hungary as well. So the big question here is that what will be the tools, what will be the instruments to really have this limitation in the future for the sector itself. Of course, the first thing would be to reduce the activities, but we up till now we did not really see actually this decoupling from the GDP. And the second tool which can play a big role here is of course the modal shift here. So instead of moving the goods on the road, we can move it on the trains, we can move it in other ways, less carbon intensive ways here. But what we see is that we do not really see this trend. If you have a look at the numbers, what we see is rather increasing. So the road share of the transport is increasing from 47 to 53% in the given period. So that's a limitation. So in the short and mid-term, we do not see really this trend, which should be changing. And of course, there is this last option, which is which we will talk about here, is that, okay, what are the technical improvements here? The technical improvements, I mean, how can we change the fuel actually in this transport segment? And then we'll talk about this electrification, hydrogen use, and other renewable fuel. So that's the big question which we would like to talk about, and we have quite good experts here to have a nice vision that how this sector and subsector will change in the future. So we are really looking forward for a fruitful discussion here. So thanks a lot for your time, and I give back the floor to András, please.
Thank you, László. Now to start our first session, it's a pleasure to welcome Professor Laurent Tavassi from the Delft University of Technology. Professor Tavassi is a leading expert in the freight logistics and will guide us through the strategic role of ERS within the decarbonization technology mix. Dear Laurie, we are ready for your presentation.
Thank you so much for the introduction, Köszönöm szépen, and I look forward to start the talk. Let me share my screen. I hope this is visible now.
Yes, it is. Yes, perfect.
Okay, so this is a shortened version of a presentation I gave earlier in Budapest on the seminar for the eCore project organized by KTI. So I've summarized it a bit, and I'm going to cut right to the chase. The background of this story is that we cannot avoid a landscape, a battery electric landscape anymore. It is not a question anymore whether this will be the dominant technology in the future for several reasons. So while 5 years ago we still had doubts that the range of electric vehicles would be limited, now it's not a question anymore. Today we have trucks on the market, 600 to 800 kilometer range, and this will grow to 1,000 kilometers as it is projected. The costs are lower than diesel vehicles already, and by 2030 it will be lower in most segments of freight transport. So this has led to a very big change in sales. Of course, China is leading the change. They're investing for about 50% in battery swapping technologies because batteries are relatively cheap and they have too many batteries, so they're trying a system where this is a critical factor. But also in Europe, the sales have picked up very quickly, and it is also projected that by 2030 more than half of the sales will be for heavy-duty vehicles, so above 12 tons, it will be electric. Now, it's not really a surprise if you look at the cost levels of the alternative technologies. So electric is cheaper than diesel, cheaper than biofuels, and much, much cheaper than hydrogen. So about a third or half of the cost of hydrogen at least. So this battle has been won basically already by the battery electric technology. So, and I will come back to that later, it's still a big surprise for me that hydrogen is still on the table even in AFIR. So the question that I want to talk about now is whether this charging facilities that have been planned and have been mandated by the European Commission are sufficient. So this AFIR plan, the Alternative Fuels Infrastructures Regulation, stipulates that every 60 kilometer there has to be charging for HDVs on the core TEN-T network by 2030. Now, as we all know, this is quite a crude network, and most of the charging will not happen on TEN-T, but will happen at depots, at the homes of different companies where they park their vehicles overnight. And a limited amount of charging is needed during the day, so for about 10 to 40% of the trips. And this is the big question, whether the AFIR facilitates this sufficiently. It does not facilitate, of course, depot charging, which will be local and regional. But many networks are already developing, which is a good sign, of course. And this kind of corridor charging at truck parkings and at new facilities is predicted to cover at least the demand. But many say, including the ASEA, the Manufacturing Companies Association, that it's about half the amount of charging points that is needed. So I think there is still a gap that has to be covered. And this will be for those companies mostly who have to charge during the day, which is a small share of all the trips. So, oops, I'm sorry, I pushed the wrong button here. I have to share again. So here I want to introduce electric road systems. This is an option which is supplementary to static charging. So we can still have charging stations, but I think we have to also consider this option as one that can alleviate the network and can be more efficient. So what is the idea behind this charging system? Of course, you charge while moving, and that has certain consequences. And these are visible here on this balance here on the scale. Like one important consequence is batteries can be smaller, because you can charge during the way, you can even charge more than you need for transportation, more for moving on the way. So every 1 kilometer of dynamic charging would give you a 2 kilometer transport. So 1 kilometer for driving and 1 additional action radius. You don't need charging breaks, because you can charge while moving. It's much more space efficient because we don't have to create new charging stations and new areas for charging. You use the road space for charging, and the overall cost will be much lower because it's more efficient and a better connection to the grid. Now, of course, there needs to be an infrastructure investment, which is not the same as a static charging infrastructure, and it requires maintenance, and it collides with the road investments and the road maintenance programs, which is, especially for the government and the road authorities, a very, very big task. But overall, economically, I mean, there have been many pilots, so we're pretty sure of the technology. There have been many calculations about payback times, and these suggest that it is very well feasible. So even with a commercial deployment, payback times for a commercial party, for DBFM, so design, build, and finance, maintain contract, would suggest payback times of 7 to 15 years, which is very, very good in the world of concessions. So this is a pretty well matured system, TRL level 8-9, and at least the system with conductive overhead lines has been tested extensively, and also the induction system is improving, and the conductive system now is being tested in France in detail. So the eCore project was conceived after these national trials to see whether a corridor would make sense and what kind of special measures would be needed to equip this corridor. Think of standardization, for example, think of continuous charging possibilities, or continuous network, and of course with the vision of the TEN-T in the background. And this corridor would stretch from Rotterdam to Budapest, and so in those countries, the national governments, the ministries funded this project together, with the Germans funding the most, and then the Dutch were contributing also a bit, and the Austrians had their own project, and in Hungary also KTI had this project to look at in more detail at the users, at the prerequisites for construction and integration with the Hungarian system of concession tolls, and also in connection to Europe. Now, this map that you see here with the yellow lines, it was not really made up using data and using a competition analysis with static charging and so on, but it helped us to get an idea that there would be a scope for this. So in the next slides, I want to go a bit more deeper in what was actually found with empirical studies. So one of the things we did in the Netherlands was that we looked at the cost-benefit analysis of a single corridor investment. So without looking at a network, we were looking at a corridor from Rotterdam to the port of towards the port of Antwerp, not entirely to the border of with Belgium, but this is a heavily used corridor by trucks. And here we found that even on this short distance, it would break even an investment after 20 to 25 years. So it's not a very good financial business case, but it would break even. Now, of course, there are uncertainties, where the main one we found was the battery price that would perturb the analysis. And the figure on the bottom right shows a study which compares the different battery price predictions, and there's still significant uncertainty there. But we, in general, find that practice is going faster than in terms of price reductions than what the theoretical studies have predicted. So they may shorten, they may lengthen the break-even period, and a full network, of course, will have better payback times. But even for the Netherlands already, this was interesting. Now, we did some other studies in the Netherlands also with more detailed data, where we used tour data, so not only the data that said that trucks move from origin to destination, like in a passenger transport model, but we would use the complete tour with different places to serve, which is the complete distance that a truck would drive once or twice a day. And here we get interesting results that about 30% of all the users would use ERS next to their depot charging, so the charging at home, or next to the stations, the charging stations that they would use. So ERS here has a market, and about 60% of the trucks would have already would be satisfied with only depot charging, so charging at night at home. But this would leave a significant market for ERS next to charging stations also, whereas charging stations would be less important than ERS. So here also we see the effect on the battery size reduction, because if everybody buys big batteries, there's no need for ERS. You know, you can reach all the places at all time, but you need also long charging stops and so on. If you have ERS, you can buy a much smaller battery, which is much cheaper. So here we also saw that only 40% of the trucks would have the biggest batteries, where at least 30–40% would have a very small battery, which would be enough with the charging stations and the dynamic lines in place to reach all their destinations. Now, this is also supported by a Swedish study. So my colleague Jakob Rockstadius is, I think, the one that has done the most analysis on this part for Sweden, where he finds that if we introduce this dynamic system, then that would reduce the number of necessary rest stop charging places with 50–60%, destination charging, which means where you can deliver your freight and charge at the same time, 40–50% less, and depot charging at night, 20–30% less. So it means, of course, there is competition between these systems, but they're complementary, and together, introducing ERS would make the whole system more efficient. And we can also look at the energy properties here and the dynamic energy properties. So it's interesting that ERS spreads the demand for energy much more. So typically what you would find with battery electric trucks is that drivers will want to charge after 4.5 hours of driving. And because that's when they have their resting time. They have a resting time of 45 minutes, so you cannot charge a full truck, but maybe partly. And that would give a peak, not in the morning hours, but around noon. And this is a system which gives a peak there where the traffic peaks, right? So we would have strong peaks. This matrix is the time-space matrix, where you can see how the energy need is spread out over time and over space along this corridor. There's also been a study a couple of years ago about how ERS influences the load on the grid and the electricity demand on the grid, and it finds that especially with vehicle-to-grid capabilities, ERS is much more much less demanding than battery electric trucks. And this is interesting because, especially in the Netherlands and also in other countries, there's severe grid congestion, and it means this could alleviate this grid congestion also. So let me continue with explaining the total costs, why they would go down. And the logic of this is that the more infrastructure you implement, of course, that would be expensive, but you would save an enormous amount on battery costs, on batteries. Now, of course, if batteries become very, very cheap, dirt cheap, then this doesn't work anymore. But at least for the foreseeable, like 10 to 15 years, we believe that this would have a strong impact. And then what we found is that if we add these two types of costs, then the minimum is somewhere around 15,000 kilometers for this small system of the Netherlands and Germany and Belgium. So it means that you can create quite a big network. And the first benefits already arrive in the first thousands of kilometers. Now, even if batteries get cheaper, this will not change much. So there's still scope for quite some investment here, which will reduce the total cost. Here in the graph, you can see that the total costs go from 0 to a 15,000 kilometer network. They're almost, well, they're not really halved, but they're reduced by 40% for everyone. So including infrastructure and including also batteries. Similar findings came from Jacob Rockstadius again. He did a study for Europe where he looked at different 10T lines here. And the dark ones are the ones which have a high level of truck transport, so 6,000 vehicles per day, average annual daily traffic. And these will be the ones which are, as he called it, a no-brainer. Great return on investment today, even if you only take into account only the heavy-duty transport. Now, of course, you can stretch this network. You can see Hungary here with more like the pinkish line and the blue line here, where you would have a price cap on the electricity costs from the service providers, or you would include light-duty vehicles, but then you cannot use the conductive overhead wire, but you have to go in-road, which means induction or in-road conductive transfer of electricity. So, and then there's the remaining part of the light blue lines, which would only be viable if we include also light-duty vehicles, which is still feasible, and I think that would create an enormous business model also for the rest of Europe. Because then vans and even trucks, which were not included in this picture, but trucks, cars, passenger cars, could also charge on the system. That could be a vision for the long-term future. So to summarize, there is a case for ERS. Yeah, it's a clear financial case, lower truck TCO, so total cost of operations, and a strong investment case for heavy routes. Yeah, so there's a limited number of routes, but at the scale of Europe with 10T, it's really conceivable. And of course, if you have a wireless ERS or in-road, so not the overhead lines, then you can capture all the traffic. So it would give a little bit of air with fleet constraints that we have now. So the grid congestion and the space constraints for using, for charging, the waiting times, that would be reduced. So we cannot move ahead now because of these space constraints, because of the grid congestion. Weight and size limits would not be critical. So what we see is that the battery is so heavy that it will use a lot of payload weight for that. There's been a payload survey recently in the UK, and looking at how much capacity trucks would lose if they would become electric. And this is like 10 to 30% of capacity, which means we would need the equivalent more of trucks on the roads, which is enormous. I mean, we can imagine an additional growth of trucks of 10 to 30%. Then finally, I think ERS has a lower adoption threshold. So what we cannot do with large battery electric trucks, because they have a completely different architecture, is to retrofit existing trucks. But this can be done with ERS, which could speed up adoption processes and make it also easier to adopt for smaller companies. So finally, I think in terms of sustainability, we see that we have large economies of scale. We need much less assets on the road with this, and we can rely more on green energy, and especially with vehicle to grid. We will be more efficient with using energy. We have more opportunities to share energy across the time, across space. And I think an argument that today should also be important is that we save critical materials because we need less batteries, and we become more independent on big manufacturers in China like BYD or manufacturers. So all in all, for Europe, this seems to be something that cannot be ignored. And but that's the problem at the moment, that it's not on the AFIR, and it's I mean, there's been a meeting the day before yesterday, I think the 19th, yes, by people from the ministries of different countries who have said to each other, we don't want to lead. None of us wants to lead. We might want to follow, but not today, which means that it's not really on the agenda. And that's I think where we could have a discussion. While it has some advantages, it comes late into the whole game of electrification. While to our eyes, it's only emerging. We've seen also only the first electric trucks on the roads, even in the Netherlands, but it's going to go very fast, and we have to realize that. And then it means that pushing a system like ERS or bringing it forward, we might already be very late. It will rely on some clear and coordinated public support, for example, through AFIR and through national governments. But it's difficult to see how we can enter this into the discourse, at least for me, which is dominated by fossil fuel companies for hydrogen and dominated by the OEMs for battery electric vehicles. So how to do this? I've submitted an opinion or some ideas for the European Commission. The deadline was yesterday for the new AFIR, but there was not too much on ERS, so I'm curious how this will go. But I'd like to leave with a positive note, which means that in the future that we could have this in-road charging, dynamic charging for all vehicles in all the roads. But that would require a revamp, of course, of all the infrastructure and infrastructure maintenance. So I'd like to leave it at this. Thank you so much for your attention.
Thank you very much, Laurie, for that insightful overview, and special thanks for delivering it according to our schedule. Moving now to the next speaker. Our next speaker is Christer Torin from Scania. He's a project manager for air mobility solution development, and he has direct experience with the practical challenges and successes of electrification. Christer, we're looking forward to your insights, please.
Thank you. So let me know if you can see my screen now.
Yes, we see.
Good. Yes, great to be here. A very interesting theme to talk about. I've talked a lot about this in many different places, and I still think it's a fantastic idea. So let's see if I can switch to the next slide now. There we go. So we need to start in this area. Why we at Scania have been working with ERS at all. So we have a purpose, a commitment to reduce our CO2 footprint. And this is from the top management, both in production and in the vehicles that we deliver to customer. And we have a tough target. We had a target of 20% reduction of CO2 until 2024. We didn't reach that, we reached 11, but we're open to that. We are not satisfied, so we have set a higher target now from 22 to 32 to reduce it by 45%. So this is steering us what we do at Scania, how we work and so on. This is a overreaching target, and we do that in several ways. We do it by introducing vehicles with lower fuel consumption. A couple of years ago, we actually had a new drivetrain that reduced consumption by 8%, which is great in our area. We also, of course, can use a lot of different sustainable fuels. But these are only short-term solutions. They will not eliminate the CO2. They will reduce it by some amount. So we know that electrification is the long-term target. We know that in the end, all the vehicles will be electric. With maybe very small veteran trucks might still use the diesel. But I would say electrification is our future. And this is going quite well. We have the infrastructure that's developed fast now. Looking at the map to the right, showing in dark green and in red charging stations that are viable for trucks or built for trucks. And the light greens are also viable for trucks. They are actually built for passenger cars, but they have space enough for a truck to be able to charge. And the MCS Mega Charge standard is being introduced this year, which can allow 750 kilowatt to begin with, and even more in the future. So you can see that at least in Western Europe, the network is quite good. By the way, this is a map made by Reno. You have the link there, or the address there, if you want to look through it yourself. Let me see how I can go to next. There we go. And also the vehicles, as we heard, they also being improved continuously. And this is taken from our commercial website. So there are no secrets. This is open information that we now have up to 560 kilowatt hours for sale. And if you use a 42-ton vehicle, you can drive more than 500 kilometers on one charge. And we also say that we are introducing MCS in the vehicle this year. So you can order a truck now with the MCS and get it delivered this year. So the infrastructure is coming and the vehicles are there, I would say. And of course, this is not the end. This is a continuous journey. But this generation is really made for long haulage. So what is the challenge then? I would say that one is space. As we heard, this is a picture from a typical German truck parking station. It's overbooked. They usually overbooked by 30% each night. That's really no space for the trucks. And if you come and say that I want to take away 20 or 30% of the space to build a charging station, that will not be popular. So that's a huge challenge. This is a layout proposal from the Hola project, which is are developing BEV and MCS charging station in Germany. And you can understand that it takes a lot of space, not only the dispensers, but also the substation, the power unit, and the bus here that is probably needed because that's a backup battery. So this is a huge challenge. And in Germany, you're not even allowed to expand your parking station. They want to keep the nature, don't want the asphalt to expand more than they do already. So this is the challenge in the future, not now, because there are not that many electric trucks on the road. And another challenge, of course, is the grid. This is just a Google Earth picture from a Grafenhausen in Germany along the Autobahn. If you calculate, it's about 50 trucks there on that side, and similar amount on the other side. And of course, they are parked there because they need to take the rest time of 45 minutes. Most of them, maybe a few of them are also sleeping overnight, daytime. But most of them will only stay the required time of 45 minutes and then continue. And if they are electric, they most likely want to charge during that time. And if they want to charge full, they need 750 kilowatts. So in that case, this would need a grid connection of 37 megawatts on this side and the equal on the other side. And let's say the best solution is a very good one. Maybe you can even out the demand because this might be the top one of the hours where there are most vehicles. So maybe you can reduce it to, let's say, 25 megawatts. You still need 50 megawatts to one parking space. And this is about a requirement of a Swedish town of 40,000 people. They consume about 50 megawatts. So you can understand this is only one of these parking places along the Autobahn. And you have to take that times a big number. I think that our colleagues here can have done the calculation more thoroughly, but this is just to explain why it will be very, very difficult in the future with this BEV solution. So, yeah, as we heard, this solves most of that problem, driving while you charge. Because you have a continuous supply of power, you don't have the peak places with peak consumption, you don't have the hours with peak consumption, but it's spread out over time and over space. And I know that Siemens, that we worked very closely with, they propose a system where you have charging stations of 2 megawatts along the road. And when it's fully deployed with all the trucks are electric, they say they need every 2 kilometers of such station. But in the beginning, you will not need it every 2 kilometers, maybe every 10 or 20, depending on how much traffic it is. But it can be improved, and in the end, let's say every 2 kilometers. But to have a lot of 2 megawatt supplies is much easier to have 150 megawatt, or mainly 50 megawatts. And as we heard, this just confirms what you heard previously. The battery can be much smaller. You only need it to drive to and from that road. And we know that most deliveries are, let's say, up to 50 kilometers from the road, and then you're at your destination, then go back. So you need one battery for 100 kilometers. So a battery of 150 to 200 kilowatt hours is more than enough in most cases. And again, you don't need to look for a charging pole when you have it, need to rest, as you will do with the electric truck. Now you know that you are coming close to the 4.5 hours where you are required to stop, and then you need to find a parking space with a charger that is free to use to get an optimal drive. With this ERS, you can stop as today when you need, because you are fully charged when you leave the road. Something didn't write, but we estimate that the truck should take between 200 and 250 kilowatt from the supply. Half of that will go for propulsion and half of it for battery charging, which means that you are entering with if you drive 100 kilometers on the road, you will have a battery range of 100 kilometers more when you leave the road than when you entered it. So there we go. So what have we done then? We started early. We actually initiated this, or Siemens approach at 2012 with a proposal. They had a truck with a pantograph, and they saw it worked, but they also wanted to work together with an OEM, and we said, of course, we want to do that. So we started to work with Siemens 2012, developing a truck, and worked fine. And a couple of years later, the Swedish government decided that let's build a pilot road in Sweden. So they did that, and that was opened 2016. It's a road of 2 kilometers, one direction, and we made 2 vehicles for that road. The road where the trucks were driven by Ernst Express, which is a commercial company. And they did daily drives, and we had a lot of visitors. 3,500 was the latest number I heard. So it's a huge interest, and most of them could also take a ride in the truck, do a round trip and see how it worked. And to the right, you can also see that we also tested it in rough conditions. And I would say it worked as a first pilot. We learned a lot, but we also did all the demonstrations, and so we were confident about the technology. This project was supposed to end at 2019, and it did that too. However, the government of Sweden did not extend it, unfortunately. I can come back to that. See if yeah. So next, Germany, and I guess a lot of you have heard about this pilot or demonstrator as well. That was in operation between 2019 and 2024 in 3 different places. This picture is taken from Frankfurt. We've had, still have 5 kilometers in one direction and 12 in the other. There was also a road in Lübeck, or is, but to 5 kilometers in 2 directions, and a third one in Baden-Württemberg on a smaller road, 3 kilometers each direction. And we built 22 vehicles for this test. The first 15 was in generation 2, and then we got the new order of 7 more that we made a third generation. So we learned a lot, and the third generation worked very, very well. The other worked too, but we improved operation and uptime immensely. So in the end, there was really no problem with uptime. We had about 10 different operators, one in Baden-Württemberg, one in Lübeck, but I think it was 8 in Frankfurt, around that. And they drove daily operation, commercial operation, and we summed it up to 3.5 million kilometers driven in total between all these 22 vehicles. So this made us very confident. It works. We see no problem with that. And so the conclusion, yeah, it works. We have the solution. However, no European country has decided to invest in it. And I would say that the bottlenecks I show with grid and space, they are not visible at the moment. They are only theoretic bottlenecks. And they do not, convince the politicians to invest in this. And they will be sorry 10 years from now when they see the problems, but maybe we can convince them and explain the future for them already now. But we as Scania, we continued with the development of sustainable technology. We have a lot of different solutions. We have e-revs with the range extender. We have fuel cell vehicles, So I think we are prepared for the future, and I would really like to see these vehicles on the road in the future. And let's see what happens. And that is the end of my presentation. Thank you very much.
Thank you very much, Christer, for sharing those practical examples. And now we have some time for the audience and your questions. Until now, as I see, we did not have any question, but still you have the chance to write or even raise your hand. Yes, we have a question from Patrick Ackerman, please.
Yes, hello. Thank you very much for organizing this webinar. I have one remark and maybe 2 questions, mainly to Lori. So one, you showed about the energy system, the spreading of the loads. Have you done any studies on looking at the synergies with renewables, especially solar? Because you see some countries there's a bottleneck on expanding solar generation because they're over-generating during the daytime, and there's a lack of demand during the day, but the trucks are really active during the day, so they could actually be a good sink for this energy. They could charge their batteries during the day and then use that power. So I don't know if you've considered that.
We are considering it now. So we have a collaboration with Enet Südhessen from Germany, DSO, and our own energy system modelers. And we're using density traffic patterns to compare them also with different markets in different countries, as you say, and different times of day, and see how the energy markets would respond to that, and where there are shortages and so on, and what kind of transfers would be needed, and what prices would result. So this is quite a big study, which is ongoing now, where we hope to have some more of this soon. But we haven't done it yet. Yeah.
So how soon is soon, if I may ask?
A month.
A month. Okay.
Yeah.
Okay. Thank you. I'll leave it at that.
Yeah, let's keep in touch.
Yeah.
But this is the next frontier, Patrick, I think. Yeah.
Thank you. Other questions?
I can actually give you a little feedback about different technologies. So we are saying at Scania that we are agnostic. We can put in any technology that the customer wants, both inductive, conductive, ground, or a wire above. But when you look at the use case, you need to have some requirements that, as I said, the power transfer need to be 200 to 250 kilowatts, and the vehicle cannot be too low to hit the ground. And today we don't see that the inductive fulfills that with the tractor that has limited space below it. So that's but if that is improved and increased, we don't see any problem switching to that. It's a good solution for the customer. I can also one more comment about the inductive. At least if we look at Germany, the right lane is full of trucks. There are no cars there. So at least in Germany, they will not share the charging facility because you will see the cars in the second lane to the right and the truck to the. So you would still need two different charging methods for cars and trucks in Germany. Might be different in other countries.
Yes, Patrick.
Yeah, just to pile on then on the in-road solutions. No, so one question I always had about the cost for a universal solution, as Christer mentioned, for it to be universal, it has to reach the power levels of the trucks, but also the installation, because we see the cost of installing an electric road system is not just the substations and the infrastructure to connect to the trucks, but closing the road and managing the roadside. And if you're putting something in the road for all vehicles to use, do you then do all lanes at the same time? And if you don't do it at the same time, you first do the truck lane, then to install on the other lane. This will be a very big headache, I think, on the construction side on the road. And that cost is going to be something that needs to be factored in. But I don't know if that's considered in the analysis that Laurie was referenced to.
No, we had a very simple approach towards costing. We did some sensitivity analysis, but 2 to 4 million per kilometer was the average figure. And of course, this can be detailed out, and we did not take into account different alternatives on the electricity connection side. And I agree, Patrick, there are complexities here that would need to be studied. Yeah, I think that will be the nice thing of having a really good big study, comprehensive study. And that I'm not sure whether that has been done yet. I mean, ECOR has touched on certain aspects as well, but more focused on the European connections than on connection to the energy grid.
Thank you. And as I don't see any other to raise his hand, we can, I think, move toward the roundtable discussion, where two our previous speakers, Laura and Christer, will be there, but I'm also pleased to welcome two additional experts to the panel. István Stranát, who is sustainability solution expert from Waberers Group, which is one of the Central Eastern Europe's leading logistic and transportation companies, and Szabolcs Balog, an e-mobility expert who has a rich experience in charging infrastructure development and basically representing the perspectives of both charging point operators and mobility service providers. I hope everybody is here and we can highlight them to see them together. If István is here, welcome, and also Szabolcs. Thank you. And the first question would be to some initial reflections on the presentation, and then István, I'll start with you. Waber is a major player in regional logistics. How does the challenge of heavy-duty decarbonization and especially the concept of ERS intersect with your current work and experiences, and what is the most interesting and challenging takeaway for you from this presentation you just heard?
Okay, welcome everyone. Just a short introduction from my side. My name is István Stranát. I'm working in the Waberers Group, and as András mentioned, Waberers is one of the biggest complex logistic company in Europe. Currently, we have around 6,000 rubber-wheeled vehicle. From this 6,000, more than half it's trailers, but we have thousands tractors, lorries, vans, refrigerated lorries. So we have three important legs in this company. One is the international market. We have around 2,000 vehicles in this segment. And the specialty of this segment that we have ultra-low connection vehicles for the international lines. And I think one of the most hardest thing that we can find some kind of vehicle in electric powered with ultra low connection or ultra low hitch. Just a few producers can make this type of vehicles until now. So our second leg is the domestic market. In this market, we have around 1,000 vehicles, vans, lorries, refrigerated lorries, and also tractors. And the third leg is the insurance company. In the domestic market, currently we have 30 alternative powered vehicles. We have 11 LNG tractors and we have 19 electric powered vehicles. From these 19 electric powered vehicles, currently we have vans, lorries, refrigerated lorries, and tractors. We started the whole project and the sustainability project from this side or from this view in 2021. So if you compare this 30 vehicles to our whole fleet, it's not so much, but this is one of the biggest in Europe currently. So I think it's a learning way, and we're just searching the way that okay, how can we decarbonize the whole transportation segment and this and the other things. So we have experiences with electric powered vehicles in Hungary, but in last year we made a test, one of our international line. We went from Hungary to Slovakia, from Slovakia to Austria, and from Austria back to Hungary. And we know that these countries are neighbor countries of Hungary, but this was international test and international line. We're managing the charging in Austria. So we have very good experiences with the vehicle, with the charging system or something. And yeah, I think the presentations which we saw was very interesting, and in my opinion that the technology is very interesting, and I think the technology is working because they have experiences, and there was a lot of pilot projects, not just a few weeks, it was years, as I saw. But I have two questions for this. One is that I saw that 2 megawatts per every second kilometer for the energy. And the second is I heard some kind of euros per kilometers. I don't know what is the exact price or exact cost for this project, but I think it's one of the key point to this solution.
Thank you, István. And now I will give the floor to Szabolcs, also some introductory remark, and please share your experience with the charging infrastructure. How do you see ARS is fitting in your professional focus and your experience? How feasible is it from your perspective? And after that, if you have also questions to the speakers, then they can answer this.
Yeah, so thank you for the market. At the moment I'm working as an independent consultant. But until March, beginning of March, I was part of with Mobility, the MVM group, and from scratches, from zero, 9 years ago we started to build EV infrastructure in Hungary, but still we didn't know what it is and how to do that. We went up to Norway to get some information and benchmark, because the most developed, still I believe the most developed environment for EVs can be found in up north, and we had very good strategic partnerships with our Scandinavian friends, and we are very happy that we could avoid all the dead end streets of the development, and we could develop in Hungary market leader EV network and market leader EMSP as well. So Mobility had, in the beginning of March, when I left Mobility, I was CEO of the company from the beginning. We built a public network with more than 1,000 charging equipment, and like 400-500 depot chargers or office chargers as well belong to our system. And beginning of March, we had about like 170,000 registered customers in our database. And our market share was about like public charging, about like 20% in the Hungarian market. So this is mobility, and this is my background. And thank you, very interesting presentations. And this ERS is a nice promise and very interesting. It brought more questions than answers to me, because I am, as András, you just mentioned, I am bringing to the picture or to the round table the CPU perspective, how we can make it technically, what are the business models, and some questions, because all of the equipment can be broken down, right? How we will make the simple things like maintenance, preventive maintenance, corrective maintenance. If something was wrong, on highway, our technicians and engineers, how they will do their work. From the other hand, what just István mentioned, prices and costs, right? We know back from the Stone Age, right, when we drove ice, that highway fuel stations were the most expensive choices, right? Fueling our cars. ERS will be in a monopolistic, I believe, ERS will be in a monopolistic situation. How we can cap the price, right? Or how we can make it feasible for logistic companies and trucks to use the system. But these are the questions. But my main question, because how I see the ERS at the moment is a wonderful technology or wonderful promise for the, I don't know, next decade or 2 decades probably. And this is, in my mind, in between the so-called traditional charging, which is like HPC and MCS, and our wonderful system. In Europe, we have a wonderful system already. Our grandfathers and great-grandfathers built it, the railway, right? So in my imagination, ERS will be somewhere in between these traditional BEV charging and the railway system, and how we can find this niche, or because I believe this will be a very good answer for corridor optimization, where very dense traffic will be in some highway corridors, and in, I don't know, in 10-15 years time, but I have more questions than answers, I believe, and then hopefully this panel will give a good opportunity to discuss some of these questions.
Thank you, Szabolcs. Lori or Krister, do you have some answer, comment on this? And also István questions?
Yeah, I can start a little bit how they managed the maintenance in Germany. The Autobahn GmbH were sort of the owner of the system. So they had some people who were supervising the system and were planning maintenance and repairing if needed and so on. So yeah, it was just business as normal after a year, because I put it in the normal flow. So that was not an issue, because they do maintenance on the highway anyway, just added one more component. So that was a no-brainer. I think the other question you placed, how will you make sure that the price is not a monopoly price and raised, and how do you divide it? That is a very interesting question. So maybe Laura has some thoughts about that.
Yeah, so I think it's not a monopolist, because of course static charging is always there, and the companies will be able to choose. So there will be pressure on the prices. Second, I think there will be a concession system in place, so it's not something that can be left completely open. And also, I mean, all the calculations so far have shown that there's even room for taxes, for additional taxes, after having a decent price. So I think it will be somewhere in between depot charging and MCS in terms of pricing, because obviously if you can charge during the night with a battery, use green electricity, save during the day, and then you take the night to charge, that will be the cheapest. But then you have to be able to make it with your operations, and so I think most companies will go for that. But what about those 40% of trips that need daytime charging? So for them, there has to be a choice. I think the risk is rather that MCS will be a monopolist without ERS. No, if the course that we have at present is that we will only have these big milence charging stations on the way, which will, I mean, I'm not saying they're a monopolist, but it will be, I think, it will be a scarce, more sparse landscape without ERS. And I think the business case looks good enough to offer decent pricing to companies. That's what David Sabon and Jacob Roxadius have looked at.
Thank you. And then I'll continue with our first block on logistics and operational reality, and then I will turn again to István. You said that Warburg has already some experience with battery electric heavy-duty trucks, even if only in the domestic market mainly. But what do you think? What are the main constraints now of these battery electric trucks to replace the conventional diesel trucks? Whether they weight, which limits the payload of these trucks, or rather the charging time and lower flexibility, or the price of the truck, or what is the main limitation for you, and what factors should be solved first to turn more to electrification of the fleet?
Okay, I think, and in my opinion, the points that you mentioned are better and better, I think, year by year, or half a year. So we have more and more efficient vehicles on the market. We have more and more charging capacity or onboard chargers on the vehicles, more and more charging capacity in the charging stations regarding some kind of megawatt charging in Europe. So I think this type of transportation will be better and better. But just like everything in the world, it has some advantages and disadvantages. So in my opinion, and what we can see, one disadvantage is the weight of the vehicles. It's not a surprise, I think, and it's not a magic. The batteries are heavier, just like a fuel tank for a fossil fuel. So our vehicles have maybe between 2 or 3 tons more weight. For example, if I mention for a tractor, and this 2 or 3 tons more weight, it's okay. We have 2 ways. We have regulation in European Union. It's 44 tons, but in Hungary it's 42 tons. So I think it's not so much difference. It's around a half a ton or a ton difference in the payload. But yes, if I checking this from the infrastructure or the road system or something, the heavier vehicles are using more heavier our roads, and yeah, it's a question, and it's a question from the maintenance side of the road. In my opinion, that the prices, it's interesting question, because 5 years ago there was a price difference. It was a huge difference between diesel powered vehicle and electric powered vehicle or some kind of alternative powered vehicle. But nowadays we can see that the diesel powered vehicles are more and more expensive year by year. But the electric powered vehicles are staying, or could be less. So I think the gap is the gap between the two technology is closer and closer. But maybe in the future, maybe in 2030, just like saw in a presentation, maybe this will be the year that it will be equal. But it depends on, I think, the configuration, the battery packs. So I think this will be a key question, the prices and the costs of the vehicles. And I saw that this type of vehicle that have less batteries, which is very good because it could be cheaper, but it have a complete pantograph system. Maybe it could be a little bit expensive more expensive because of the additional system. So it's a question for me that, okay, how it's working, and okay, it needs less battery, but it needs additional pantograph system. So if I say that diesel vehicle price is X, the electric powered vehicles is X plus epsilon, because there is a surcharge now. But if I mention, or if I thinking that this type of vehicle, okay, what is the price gap, or it's cheaper than an totally electric powered vehicle, or it's a bit more expensive as a diesel powered vehicle. So it's a question for me.
Yeah, you mentioned the weight difference. Yes, I wanted to ask you, Christer, on this, because you mentioned that you have a 40-ton tracks with more than 500 kilometer range. However, what weight difference could be achieved and cost difference if we have an ERS and compatible track with the pantograph together?
Yeah, I can't give you the exact numbers, but the target is that if you start with this 560 kilowatt hour vehicle, you remove half of that battery, and that the weight and the cost of the battery that you take away is higher than the weight and the cost of the pantograph. So if you compare with that vehicle, the pantograph vehicle will be lighter and cheaper. But of course, I can't say how much. And that is the long-term target. Maybe not the first 10 trucks, but when you're up in volume, that definitely is possible, because the pantograph part is not that difficult. First, you have the pantograph, which is a lot of not so many mechanical things that you put together. And then the other main part is the DC-DC converter, power electronics. That's also possible to source for a decent cost. So it's not that complicated when you look at the details. So that's my answer. It will be cheaper and lighter, but how much I can't say.
Thank you. Lori, you had the figures on the total cost of ownership and the development on these. You mentioned mainly the reduced size of battery as a driver,
Yes.
a main advantage of ERS. So are there other main differences and main drivers of TCO besides the battery size?
Yes, well, of course, the waiting and resting times, if companies cannot fully align charging with the resting times, then that will be an extra cost as well. I don't expect these to be very high, but it will depend very much on the segment. So if it's largely plannable, long distance and kind of unstressed traffic, then it's possible. But if it's in a complicated system, it might be more challenging. But that's, I think, of course, queuing is an issue. Yeah, so if you have if all the trucks leave at 7 in the country, or at 6 or at 5, and they all are resting in the period after 4.5 hours, then you will have huge queues depending on where the traffic is going. And if you haven't designed the locations well of these charging stations, then you will have a huge problem. So at the moment, these locations are not really well studied through. So we still have some way to go before we can say what the real cost, these operational costs will be. But indeed, so I think I heard a figure of 20,000 euros for a complete pantograph system, but this may be old. But I mean, compared to the battery cost, it's really low. And then, of course, there are some other things that need to be taken into account. But I think all in all, I can only support the idea that it will be cheaper, much cheaper than batteries. And I also find it interesting to see what the real payload effect would be. I added in the chat the reference to the UK survey about payload loss. They have asked carriers in the UK to give an estimate of how much payload it would cost them. So as long as we have all the exemptions in place at the European level, it's not such a huge issue, but this may change. And this may for carriers be an additional cost. Yeah.
Just want to add one more thing about the weights. Even though you're allowed to have 42 or even 44 tons, you still have the limitation of each axle. So maybe you need to switch from a 4x2 to a 6x2 because of that. Have to remember that. Istvan, I guess you know that better than I do, because you maybe have something to add to that, Istvan. Would you agree?
Yeah, maybe the additional axle, some kind of solution could be had, but if we have additional axles or axle, maybe the vehicle could be longer. So it's another question that, okay, the length of the vehicles in Hungary, there is different regulations. If I compare it, for example, some kind of other European countries. So yes, it's interesting question, I think.
I think that's clear.
Sorry.
Yes. Yeah. You can.
Yeah, I had one additional thought, András. Thank you. So
yes.
There was a discussion that we had last week. We had the Smart Freight Week in Amsterdam, which was all about electrification, road electrification, and Transport and Environment, the NGO from Brussels, was there, and their main point was that, and Toren, you'll have to engage on this because it concerns the manufacturers, the OEMs, that there would be huge pressure. ASEA was present, the Automotive Manufacturers Association, and there was a debate between TNE and ASEA that ASEA was saying, yeah, now we need the government to help us to spur demand for electric trucks. And TNE said, well, that will happen by itself because the Chinese are coming in. They will be producing a truck, a very cheap electric truck for 150,000 euros. And the manufacturers will have to lower their prices because the prices are now kept artificially high. Maybe you can comment on that, Toren, as OEM, what that means.
That is a challenge, and we know that they're coming. We know that we have some time before it will take quite a long time before they reach our quality and uptime. But of course, they like the Japanese cars in the 70s weren't that good. Now they are fantastic. So, of course, there's a possibility to increase that. But we have some time to work and be able to compete with them before that. And they also, of course, need to build up a service network. But I know that they're doing that as well. I think the service network is as important as the vehicle itself. So yeah, it's a challenge. We know it and we follow it, and we work hard to. And we don't want to stop them. We want to be as good as them.
Mm-hmm. Thank you.
But we also want a fair challenge. Of course, if the government pays 30% of the cost, of course, we will need to put 30% tax or all customer on that, of course. But in a fair competition, we need to be able to compete with them.
That's great. We turn from logistics to energy market and infrastructure. And I will ask Szabolcs, because Christopher showed that the single charging hub might need 37 megawatt capacity, which is a medium-sized town in Europe. How do you see this from infrastructure developer point of view? That how huge problem is it now currently in Europe? And is it realistic, these numbers, and how do you see that dynamic charging and overhead charging can be a solution for that?
Yeah, so my mic is on. Yeah, it's like 37, 30, 40 megawatt. It's almost like a small power plant, right? It's huge. It's vast power, but So I have just experience from Hungary, like either the DSOs or the network operators, either they can provide it or not, right? So there is no in between. I mean, there are some spots and there are some parts of the network of their grid where they are able to provide. Okay, I'm not talking about like 30, 40 megawatt, but like maybe just 3-4 megawatt. Either they can build this network connection or not. This is at the moment. And of course, I know that not only in Hungary, but everywhere in the EU, there is massive work on grid development, because not only for the EVs, but from lots of other like PVs and other technologies are required the much robust network behind them. But my question is like, if we have this ERS, still it needs network development, but not, it's spread out, right? It's not just in one location, but either it's spread out along the motorway or the highway, which means, based on my experience, where the network operator could provide us the required capacity, still it was a very visible amount of cost, what was the development cost, but the location really mattered. I mean, there were some highway rest areas where 10 times or sometimes it's like 50 times more expensive was the POD, the network connection point infrastructure building than other parts of the network. According to my understanding, if ERS is also all along the highway, so there will be some parts of the highway which are very far from or those, I would say, white spots of the network, where it will be very expensive to bring the power to those parts of the highway. So this is one observation from my side, basically, and it can be. But from the other side, as we could see in Hungary, like the PVs are many PV developments we had, and I think even on European level it was kind of recognizable. And luckily these PVs and PV parks are in the middle of nowhere. And supposedly these are close or not too far from these, hopefully these white spots of the grid, where it would be very expensive to develop that network. So it can be some sort of solution or optimization. So there are still lots of questions, but it's not easy. I believe it's not a simple answer that, yeah, it is better or easier to develop the network in some discrete point with high 30, 40, 50 megawatt network connection point, or all over the highway. Of course, like in the Benelux countries, probably there are not big differences. Hungary is like a mid-sized small country, but I believe that like in Germany or those countries where the cities are or the DSO networks are not that dense, there are huge differences of the cost of the network development to provide the suitable power for this ERS system.
I can follow up a little bit on that. One thing that's important to remember, that the ERS system does not have to be complete. You will have gaps in places where it's difficult to build the wire, or where it's too difficult to bring in the power. You can have a gap of 10, 20, 30 kilometers without any problem, because you have the battery. And there will be gaps where there have to be gaps where there are special situations where it's impossible to build. But that's not a problem. That's a feature of the system, that you can have gaps. So, but still I agree. Of course, it's not super simple to build a lot of 2 megawatt charging places. But I think it's easier than to build these mega supplies at certain places. Yeah, so that was my comment.
Laurie, do you have any comment on this?
A small addition only. I totally agree with Torren, but I think the business model is such that it will also not be viable to have ERS. So a mix of static and dynamic charging is perfectly fine. And I think it now shows that it's a really good business case for links with more than 6,000 trucks a day. I mean, that's quite something, right? There's not so many places in Europe, and it's quite centralized, and Hungary is at the edge of this. So yeah, maybe until Budapest, but then beyond that, probably not. And only if you can capture additional cars and vans and everyone who drives on the road. But that will be a different story, because then it's ERS for all. So ERS only for trucks, I think, has indeed a limited reach. And I think that's why the two can live perfectly together. You know, they're complementary. And then it will not be in the middle of nowhere where there's no electricity, or where you don't have heavy power lines.
István, what is your experience with installing high-capacity chargers at your own depots? Because depot charging is maybe the most important now for you. And as we see from figures, maybe from Lori, that the first charging solution to replace by ERS is the stationary charging at the hubs near the motorways, but to some extent also the depot charging can be replaced as well. Maybe for infrastructure development at the depots can be also a hurdle. How do you see this?
Yes, currently we have our own depot charging infrastructure. In our 2 depots, we have AC and DC chargers. AC chargers for the smaller vehicles, some kind of vans or smaller lorries, and the DC chargers, of course, for the tractors and for bigger lorries or refrigerated lorries. And our charging procedure, it depends on the exact operation, because we have day and night operation where the vehicles just stop for charging, for example, 1.5 hours or for 2 hours to charging, and after this the new driver come and bring the vehicle to the operation. But we have operations when the driver arrive and start at 4 a.m. and finish maybe 2 p.m. or 3 p.m. and after this we can charge the vehicle, and we have time to charging the vehicles. So it absolutely depends on the exact operation. But in my opinion, this ERS system could be worked from technical side. I think it's not a question, and it could be work, for example, for our operations, our international lines, because we have a lot of lines from Budapest to the west. So I think it could be work, but as just Szabolcs mentioned, that this 2 megawatt per every second kilometer, or just this huge megawatt installation, it's a question in Hungary, because as I mentioned, we have our depot charging system, but if you would like to put one additional charger or bigger charging capacity, I think we have to, or we will need to contact the electricity network. So yes, it's.
I just need to compliment that is the case when all the trucks use ERS at the same time, and you have 10 trucks per kilometer. That's when you need that kind of supply, and of course you don't need that in the beginning, and not maybe even in the end, and then you just adapt. So you put in how much that is needed. So don't think too much about the 2 kilometer. Maybe in the beginning you can do it every 10 or 20, and then you increase when the traffic increases.
Okay.
Szabolcs, how do you see this problem envisaged by both speakers, that basically without ERS solving the charging problem of the HDVs is so huge that maybe it's not even possible, not very operational to solve. So basically ERS is needed. How do you see that? It is so crucial, or it can be only some efficient adapt, but you would be more confident that you could solve this problem with stationary hubs, stationary charging?
It's difficult to answer to it, right? Because I wouldn't I'm not sure. I mean, yeah, it can be. So ERS, I believe it's a very good optimization tool, can be in the future, of course. But what I would bring into this picture is the railway system as well, right? So I believe we are talking about the transportation decarbonization. We have already a system, but at least in Hungary, I know that we don't really exploit all the advantages of that, and even for trucks, it could be used because that can be a solution. But of course, between the hub or depot charging and the like so-called traditional like MCS and HBC and railway, there's a room probably in the future for ERS. Of course, it's always question of the economics and the costs and technically how we saw it, and even like OEMs, right? If how many vehicles, so chicken and egg question, how many trucks we will. So it's lots of questions, but it was like very similar, this discussion what we had like back to like at least in Hungary 2017, when there was a two competitive technology like hydrogen and BEVs, right? Which will be the winner. So in 2017 we didn't know it at all. But now it seems that BEVs won, or at least in the next 10, 15 years, it looks like, and it's very important to keep alive these systems and all these ideas, right? And we will see how the environmental will develop. But I wouldn't put just token or money on just one technology here.
Yeah, sure. We should forget the railway system. That is why Laszlo also made the point in the introduction that model shift will be a more important step before. But irrespective of how much volume we can shift to railways, there will be a huge amount that will remain on the roads. I guess all the speakers will agree with this. And the question is what to do with those volumes, Laurie.
Yeah, so I think what we're doing now is exactly putting all our cards on one thing. So I mean, hydrogen is clearly out, but the ERS is there to gain a bit of resilience and flexibility, and I believe that rail cannot provide this, not from an environmental level and not from a service level point of view. So if we electrify the trucks, I don't see the benefit. Maybe in energy use, a bit more aggregation, so a bit more economies of scale, but the rail is totally incapable of providing the service level that road provides. So I don't think that this is a battle that we need to. I mean, we are fighting every day to help improve rail transport through many ways, and infrastructure and regulation and subsidies, and the modal shift ambitions have been there for decades, but nothing has been realized. I mean, one could argue that it would have been worse if we wouldn't have had the policies, but then the policies have also been scrutinized, and also by the European Chamber of Commerce, and or what is it, the European Court of Auditors, even more important. So they looked at this subsidy scheme of Marco Polo and found that it's a waste of money. So I think intermodal transport, also by waterways over the Danube and also across the Alps, it has its place, but it can only survive under strict regulation and under constraints of permits and so on. And rail has a very different market. It's mostly in bulk and in containers and system transport for cars and so on, where as soon as it has to become a little bit more flexible and a little bit cheaper, then a bit faster, then it moves very quickly to road. So, I mean, we can debate all kind of scenarios in which roads will be severely taxed, severely constrained and so on. But then, I mean, if we are 10, 15 years down the road, then trucks will be automated. Right? I mean, it's around the corner. So, and then there's no reason to stop for charging anymore because you don't have a driver or for resting even. So then ERS becomes even more beneficial, and then it becomes 40% cheaper trucking, or 30-40% cheaper, and there's no reason to do anything else. So I think we should focus on making sure that we can keep using road by a huge community. I mean, now we only see the beginning, of course. The first electric trucks are being bought, by this will explode, and then where do we get the energy? Where do we get the resilience? I think that's the main problem.
And I can just agree there. And with Scania, we don't see the trains as a competitor, but a complement, and they have different customers, different use cases. But we know that there will always be a need for a truck. Trains can't do everything. But we really want the trains to work better than today. So we're not opposing that. But I also know that I also heard that the delays in Germany, when you take a train in Germany now, you don't know when you will reach your destination. That's my experience anyway. And I heard other people saying the same thing. And one reason is that they have increased the amount of goods on the train, on the tracks. So they are more crowded now. And so every small disturbance will be sort of spread out in the system.
I heard that Merz even has said that the trains in Germany are becoming a risk for democracy because the citizens, they lose faith in government. So I know countries where you don't need trains for that, but it's I think it's really seen as a very serious problem now.
But the point in this discussion is that trains are used a lot in Germany, and you can't really increase it without building more tracks.
Yeah, and I think the world, I mean, we cannot do without trains because they carry a very important segments, or they're the backbone of very important segments of industry. But we are also studying very flexible train systems where you have individual pods like single wagon loads, autonomous, all completely governed by agentic logistics and all completely governed as system optimum. But this is a very far, far future. So we're even struggling to get ERTMS going on the rail. So sorry to be a bit long. Please, András.
Oh, no problem. So we're turning back to the electrified road transportation, and it seems that either we're talking about stationary charging or dynamic charging. Trucks will be connected to the grid for a long time period, which raised the question of the bi-directional charging, so the possibility to feeding back to the grid when it needs, which has two sides. First, it can provide some flexibility to the system. Maybe Szabolcs could react on this and the rationality on this flexibility and the need. But on the other hand, it could generate an additional revenue for the fleet operator. So, for example, to Bavaria as well. Also, in the case of stationary charging, while they're just parking in a depot, even at home or anywhere, the truck does not move at all, but still generates some revenue. How do you see these options? How realistic they are? Maybe Szabolcs first.
Yeah, it's like I can bring here to my experience as a CPO, right, in Hungary, and because always we kept our eyes open and tried to bring all the potential extra upsides what can support our business, right? Because we were always on a very, very thin ice financially as a CPO. And bidirectional charging is in the air always, and on paper it looks very nice, but in reality, I could say it doesn't work at the moment. It's like the one very strong technical burden here is like the degradation of the batteries. I mean, it's like, every cycle is like degrading the vehicle. And I'm looking to Torren, it's like, yeah, it's like one of the most valuable part of the EVs is the battery. And who would risk the lifetime of the vehicle to get some pennies, right? Not really tangible money in flow, just to be part of like a trial or a pilot, and shortening the lifetime of the EVs, and especially of trucks, for instance, right? So this is very important. I believe that we need a technical or technological breakthrough, to have such a battery technology where basically we have infinite number of cycles, right? So if it will be reality, then so I believe this is very important for that. So technical side. From business side, even if it would be solved, even on business side, we couldn't really experience any positive model for that, because on paper it looks nice, yeah, like peak shaving, and when it is like the spot prices are up, and I can provide back to the network energy from the batteries and load when it's in a valley or deep valley, but when I am giving back, so there are many players are here, because there is so who is getting that money, like the owner of the trucks or the EVs, or the CPO, or the energy trader, or the network operator, or or I believe that there should be some aggregators, and then those companies would be the winner if they can connect in the future thousands or 10,000s of vehicles. But first, in my opinion, it's very important to have a very good technology for batteries where, I don't know, the charging and the recharging cycles can be up to, I don't know, like hundreds of thousands. And this is my opinion, basically. And yeah.
István, how do you see this from a fleet operator point of view? Have you considered this opportunity?
Yeah, it's as I mentioned, we started 5 years ago. This electric powered, so using these electric powered vehicles, and I think the batteries, it's a key questions in the electric powered vehicles. Currently, we have lithium-ion battery technologies, but nowadays there are NMCs, LFPs, so it's a lot of option for the vehicles, and every different types of batteries have different types of advantages and disadvantages: energy density, lifetime, charging capacities, etc., etc. So I think it depends on the batteries, what we are using. It depends on the vehicle. For example, if the vehicle have just like a heat pump or some kind of additional unit to managing the battery, I think we can make them a longer lifetime with these solutions or with these units. So.
Thank you. Laurie, do you have anything to add? Or
well, I'm starting to develop some sympathy for István's job, because I mean, you should write a book about how complicated your life has become as a fleet operator with all these new technologies and so many options, so many choices, and so many uncertainties to consider. It's unbelievable. No, I have, in seriousness, I have two small additions. One is that a drawback of ERS is that batteries are smaller, so you have less capacity to play with. And I think that's the difference with the traditional system of static charging. An advantage of ERS may also be that it is predicted that batteries will live longer because you don't use the batteries when you use ERS. You have a direct connection to the motor, to the engine. So it saves battery life in that sense. And how this balances out with V2G, I don't know. But of course, it's an important point of attention.
And I can also add a few things. I think the technology is the easy part of this vehicle to grid. I think even the standard is released, and from the vehicle point of view, we need to change some software because we use the regular charging interface. If we talk a static charging now, it's just a regular CCS or MCS interface that we use, and the current goes in the opposite direction. So it's the charging station that need to have a bidirectional function so you can actually return. So that is the easy part. The difficult part, I think all of you have mentioned. Who get the money? Is it worth it? How does it affect the battery and so on? So I think you said everything already.
And turn to our last topic on the regulation and standardization. How do we complement this? Laurent, how do you see the big picture of feasibility and especially on standardization? What is the primary bottleneck? Is the lack of unified technology or financial gap or real lack of interest from the key stakeholders?
Do you mean the standard from the standardization point of view of? Or?
Yeah. I mean, generally, the feasibility, the whole ERS system, and within this, the gender standardization is the crucial point, or rather, the financial.
So thank you. So standardization can develop organically, right? So as we have seen with charging systems, where Tesla had its own system, and now we have several systems in place of coalitions which are functioning pretty well, and also communication between standards is going well. So of course, it would be better if especially if we focus on corridors, you don't charge ERS everywhere, but you have ERS on a selected number of links that these are coordinated somehow. So you don't have to switch. Like if you try to run a train from the Netherlands to Hungary, you have to switch voltages and locomotives and drivers and everything. It's I wouldn't say it's a joke, but it's terribly complicated, and we don't want this for ERS. But so I think some form of standardization would be useful. But then again, it's relatively easy to decouple and couple back, and if it's all needed in the software, then probably it's doable. Yeah. So if we agree on some basics, no, I think at the moment it's not technological hurdles. At the moment, it's merely the fact that it's already so bloody complicated, everything that's happening already, with chargers, with MCS, with trucks, with the Chinese, you cannot name a topic and it's already very complicated. And now there comes somebody who has another idea of another complementary technology. I think it's just too much for people to absorb. That's what I'm seeing around me. And even though the technology is there, the economics make sense. It's not something that people are ready to adopt, and at different levels, governments, companies. I can see the headaches of everyone when we talk about this. So I think it's that we're in that stage of an adoption curve, and I just hope that it will be considered seriously, because we are seeing other systems now that are obsolete, and that the money that goes to hydrogen, in my personal opinion, could also go somewhere else.
Christer, how do you see this diversity of standards and potential technologies from manufacturer point of view? Is it really not so huge problem as Laurie described? Or how could you adjust your technology and your trucks to different kind of charging solutions? Standard.
I would say, but to begin with, there is a standard now for the catenary or the overhead solution. There is a standard released on a European level, so that is defined how it should look, and hopefully that will be followed all over Europe when we build it. But I would say we have an interface in the vehicle, and we can connect any charging solution to that interface. Of course, we need some design and some parts and installation, of course, but in theory, in a way, the interface will be the same, how we enter the energy into the vehicle, the power. But I would say, I will be very open now. Our competitors in Europe are not so fond about ERS. And if ASEA is not proposing or pushing for ERS, I don't think the politicians dare to take it further. So we are quite alone at Scania. And I know that DAF are also working on it. So I think DAF and Scania we are very positive. DAF are probably also somewhat positive, but the others are not, and they are also big companies. So I think that's the major challenge why you don't see it fly in Europe. I can say one more thing though. It looks like China will take the next step and build longer roads. We haven't seen it on the ground yet, but they have big plans to do it. And if they decide to do it, it's very quick. Like the trains, develop a huge network in just a few years. So by 2030, if they go with the plans that we have seen, they will have a quite big network by 2030. And then I think there might be a different kind of push in Europe, what we should do.
Thank you. And you mentioned this overhead line. Scania is devoted to this technology, but what if the decision makers would dream much bigger and they envisage a world where every vehicle, every road vehicle could be charged dynamically? So they want to go for the inductive technology. How could you adapt on this also?
Yeah. If we fulfill the requirements with the power transfer and it's not too low, not too close to the ground, we need the ground clearance. I think that's the two major issues that we haven't seen yet. But from a technical point of view, that can be integrated. But then, of course, we need to look at the cost and the use case and all that. But as I said, we are agnostic. We integrate anything that the customer wants and want to pay for.
Yeah, and it's a good point to turn on the other manufacturers. You mentioned that they not really open for these technologies. I'm not sure whether they don't want to fulfill the needs of their customers, or they have something other reasons to do so. So how do you see this market of manufacturers and their willingness to any kind of decarbonized pathway to follow? That basically, is it about the margins, and the higher margins can be produced on diesel trucks, or what is the problem?
I think you need to ask those companies. I don't dare to talk in their name. I don't know.
Okay. On this, maybe we can also define this as a chicken or egg situation, that which one comes first. But it seems that as we until we don't have the network, then basically fleet operators cannot do anything that much. But how do you say, István, what will be assuring to you what time would you consider to buy the first maybe Scania ERS compatible truck, and what kind of network availability, or what will be the key point when you would consider?
Okay, in my opinion, I can see the technology, and I think it's working, and we can saw the pilots, and it worked very well, as I saw in the presentations. So I think the technology is ready, and I see the advantages that, okay, less batteries, okay, additional pantograph, but less weight of the total vehicle. So, but I can see the disadvantages. For example, the infrastructure. I think it will be a huge investment in the electricity, and a huge investment from the suppliers. And the second is the maintenance of this infrastructure. So I think it will be an additional extra cost for this. So if I can see the total the TCO of this project, I think it's interesting if I compare it, for example, battery electric vehicle or a diesel powered vehicle, or a diesel powered vehicle with HV100. So a lot of questions. So yeah, yeah. So and for example, in this case, the logistic supplier need a dedicated fleet. So for example, if 1 week we are using one vehicle, for example, in Netherlands, and the next week we can use this vehicle in Poland or Romania or Serbia or something. But in this case, in this ERS technology, we need dedicated fleet for these roads, or for these routes and these countries. So yeah, I think the technology is working. It depends on the TCOs and the maintenance of the infrastructure.
Yes, it seems the networks go first. Then I asked Szabolcs that what do you think? What could be the helping driver for network developers? How can they subsidize, and what could be the main bottlenecks to solve?
From the very beginning, it's like very similar, I believe, to BEVs. It's pure BEVs. It's like policy makers has to support the technology, right, and heavy subsidies. So this is because of course, who is?
So it is only money, nothing else, like
not only
regulation.
Not only money, but without that, I'm not sure who would step in it, right, or who would do it, who would build a. So it's somewhere we have to understand that if there's a new technology, everybody who is investing in the technology, they need a payback, right? And so it's important. And of course, in the very beginning, of course, as just István mentioned, of course, they won't have trucks if the infrastructure is not ready. So, and always for the very first step in a new technology, I think it won't work if it's not heavily subsidized.
Thank you. At this point, I will again open the floor for the audience to if they have any questions. We still like 10 minutes to for their questions. Please, Anyone who have... László, the floor is yours.
Yeah, thank you very much. I mean, I'm not an expert in that one, so I'm a interested reader of these stuff. But from the conversation what we had here, I have a big question here that we see a lot of players, lots of different technologies which could come in play, and you say that you need a lot of subsidy and a lot of harmonization as well. So in that sense, what I have a fear is that at least in 2 dimension, China and maybe other countries are a bit more in an advantageous situation, that they have this more central planning type of situation. So if decide something, they can go on a big scale, and they are more brave on subsidizing some of the sectors, which in Europe is more difficult because of more rules and because you have various nations going in various directions. So the question for me that aren't we afraid of that China will invent these things and then it will push it on us, both the manufacturing, both the technology, know-how, or it's different. So I'm wrong in that sense. So what do you think about that?
Well, I would say I think you're completely right. The Chinese have been to Europe and looked at the pilot installations in Lübeck and learn a lot. So yeah, they see and learn and go back and do the same thing.
I think one thing is to have the same course as China and to be faster, quicker, and keep them out. And the other one is to have a course which will keep us behind. I think some manufacturers are still aiming for e-fuels based on hydrogen. I think that's a mistake. Yeah, so and I think that will make the battle more difficult. And focusing on the landscape which is imminent, I think is very important, and forgetting everything else. And the landscape, if it's electric, we can still debate different charging solutions. But if the landscape that will not be realized is in the way of charging solutions for the electric landscape, I think that's a problem. So, and I think that we should first look at whether we are doing the smart things and then look at the competition. I think the competition is there, and China will exert a lot of pressure also, but then we have to protect our own markets.
Thank you.
Other question, maybe? Yes, Peter Bajor.
Okay. Hello, everyone. Thank you for the presentations and this whole webinar. It's very nice that we have such long discussion. So congratulations. My comment or thought regarding this future of the ERS and the electrified road transport overall, one policy instrument, what do you think about, or if you have any experience? We are thinking about that gradual sanctions on diesel long haul, which means that the toll system considers not only how many kilometers the truck is driving, but how long the route is. So over, let's say, some 100 kilometers, the same diesel vehicle will be charged with higher tolling, which means that at least the ones who are really doing the long haul are a bit pushed towards electrification. What do you think? Do you know any regulation in progress regarding to this? Because from our point of view, this can help a lot. And the other thing, just to refresh from yesterday, David Sebon in the eCore community, he shared with us that in India and China, they are strongly thinking in the ERS system. So they are not just thinking on, they started the development, which means that Europe can lose the advantage, not only in Europe, but also on other markets like South America, Africa, anywhere. So that also can be a competitive advantage for Europe if we are in time with this kind of developments. Thank you.
Can I, Andras, may I?
Yes.
So,
yeah, sure.
Peter, great question. We have the perfect system for you in the Netherlands. So we are starting this year a kilometer charge, which will charge those that drive long distances and with diesel more than those who drive short distances because it is a kilometer charge. Now, the trick about this system, which is in itself not so surprising, is that all the revenues are recycled. They don't go to the Treasury, so the Minister of Finance, but they're recycled by the Ministry of Transport. This was a deal between the sector and the ministry, where Treasury was left with empty hands. And everybody's happy because then we can subsidize companies in the difficult transport sector to invest where they wouldn't invest otherwise, which means buying electric trucks or buying digitalization systems. Yeah, so this is something that where we can stimulate those investments that matter most for the sector, and this for our small country, this is $500 million a year. Yeah, so this is quite some money. We can use this also for ERS if we want. We had made some reservations, but with the current wind blowing, even in the Netherlands, it will probably not be spent on ERS. But still, if we can use this, I think that would be a nice incentive. But it requires a special trick. Yeah. So
yeah, and if you can extend it to the European level.
Well, yeah, we are replacing the Euro vignette with this. So if there's not much to replace, I think all the countries have tolls already.
Okay,
yeah.
I can also comment a little bit.
Laurie, sorry, sorry, just a moment, because probably I was not clear. I'm not talking about pay according to the distance you are traveling. That's normal in Europe.
Yes.
But if you are driving with the same truck, if you are driving over 200, 300 kilometers, then the next kilometer, what is above, you must pay more per kilometer. So to try to encourage to decarbonize the long haul faster, and if you still choose to use the diesel truck for 600-700 kilometers, then you must pay an extra charge for that.
Just a short comment there, and I think Isfang will support me. We know that operators have very low margins, so I don't think we can add any more cost to them. So better would be to subsidize the electric vehicles in some way, at a charger vehicle or whatever. I think the carrot is a better thing than the whip.
Yeah, this would be considered unfair, I think, also from the sector's point of view, but I don't want to speak for Istvan.
Yeah, I think it's a transportation question and organization or organizing question in this topic. So it's interesting idea. It could be work maybe, but nowadays the toll fees are different in the countries. So there are some countries where there is no toll fees for electric powered vehicles. There are some countries, for example, in Hungary, it's 80% of the toll fee if I compare to the diesel powered vehicles. So it's a 20% difference. So it depends on the exact country that what is the situation with the toll fee.
Well, we are out of time and there are no other hands raised. I'd like to thank you to all speakers and panelists, and also to the audience for active discussion. I learned a lot. I hope others are in the same situation. And I will give the floor for a couple of minutes back to Laszlo for some closing remarks.
So thanks a lot for everyone. I mean, thanks a lot mainly for the presenter and the participants for the active discussion. As a bit of outsider, because András is leading the transport group, I think it was a very interesting workshop in that sense that we covered many issues. What I learned from it is that we are really in a situation where we have lots of innovation ongoing in ERS, what we learn now. And we learn as well that it's a very complex issue because we see many players here. So we see infrastructure operators, vehicle manufacturers, electricity system operators, DSOs and TSOs here. So we see that it's a difficult subject. So lots of questions arrive which I did not even think beforehand. And in that sense, what I'm really think why this was useful, that in that sense it shows me at least, and maybe the others were already aware of it, that it will not be an easy solution here. And I agree with many of you as well, mainly Lori as well, that if we do not manage to have very clear directions where we are heading for, then probably there will be others who would drive this market and tell how should we organize these things. And I'm a bit afraid that it will not be a similar situation what we have seen with, for example, with photovoltaic and wind generation, where Europe was clearly in an advancing region. It might happen very easily here that if we are not taking strong and serious decisions here this stage, then we'll be far over from the early stage. So that's bad news in that sense. And then maybe one more issue here is that what would be very nice to see that if there are really steps forward which are let's say, non-hurting solution. What I mean that I feel a bit of consensus here that any direction we go with ERS, whether it's, for example, this overhead charging or induction charging, one big question that you need a strong investment in electric network by the motorways. Any solutions which you would do there, you have to think of it. So you probably have to start thinking together and planning together with the TSOs and DSOs in that sense that what are the good solutions here, because then at least in steps where we don't see any sunk cost or any losses, we can go in a direction which can have many various type of innovation solution here. So thanks a lot for this insight, what you shared with us, and I think it will be still a very strong debate in the coming future, but let's hope it will go in a good direction where most of the participants will see their role and they will see their winning situation in the future. So really thank you very much for your insight, and thanks a lot for the organizers as well. I mean, András and Katalin, who was behind the organization teams as well. So thanks a lot for contribution, and see you maybe in the next workshop or similar occasion at REC. So thanks a lot.
Thank you.
Thank you.